So what we talked about last time was there's a few different ways to talk about inverse functions. You need to be familiar with those. So one way to talk about inverse tangent is with this that looks like a little -1 exponent. Or you can say arctangent. These mean the same thing. This is kind of nice, like, if you're talking about it in a paper and you don't want to try to look at that symbol, you can just quickly type in arctangent. Arctangent, same as inverse tangent. Arc cosine, same as inverse cosine. Arc sine, same as inverse sine. There's different ways to write it. Questions will change from question to question. Okay, so last time we did talk about how we had been previously using the unit circle. So if you know where 30 degrees is, and you have the point there memorized, you should know that cosine's the x and sine's the y. Only when talking about unit circle. But to understand what we're doing and why we're doing, we really need to kind of slow down and think about the process here. For this one, the input into the sine function was an angle of 30 degrees, and the output, what it equaled, is a ratio, 1:2. For every one length in the opposite, there's 2 in length in the hypotenuse. Okay. Well, inverse functions, they're just where we're swapping the input and the output. So we're switching, we're no longer going to be plugging in an angle, we're going to be plugging in a ratio. And we're no longer going to be getting a ratio, we're going to be getting an angle instead. So the question types that we're going to be doing are things like, what is arc sine of square root of 3 over 2? So you still have to know the unit circle. You've got to know the unit circle well enough to know where sine is square root of 3 over 2. But sine of square root of 3 over 2 infinitely many places. It's square root of 3 over 2 at pi over 3. Also at pi over 3. Also at 7 pi over 3. I could just keep adding 2 pi or subtracting 2 pi, and I can give all the coterminal numbers. But really, only one of those is our answer. So before I tell you how to know which one is your answer and what you need to memorize, I want you to have some background to it. And not just be able to get the answer, but understand how we're doing what we're doing. But in this case, our input, what I'm plugging into an inverse sine function, is the ratio. And so now the output is an angle. So inverse functions, you're switching the input and the output. So with trig, that means we're switching the angle with the ratio. Regular sine, plug in an angle, spits out a ratio. Inverse sine, you plug in a ratio, it spits out an angle. That's all that inverse functions do. Okay, so to help you understand that, there's a few things from algebra number 2 that it's helpful for you to know about inverse functions, for you to understand why we're doing what we're doing. So, in algebra, if you wanted to find a function's inverse, your teacher probably told you to swap x and y and solve for y. But it's just that your x was really your input, and your y was your output. So when your teacher told you to switch x and y, they're really asking you to swap the input with the output. Okay. So think of it more as input and output, because that applies to this. You don't want to think of it as x and y, which are expressions. Okay. The other thing, and this is kind of for you to understand where the stuff is coming from, it's going to happen here in the next 60 seconds. In algebra, for a function's inverse to be a function, it has to be what we call one-to-one. And a quick way for you to determine if something is one-to-one is, does it pass the vertical line test? Vertical line test tells you whether it's a function or not. And then if it also passed the horizontal line test, if it passes both, then it is a one-to-one function. And the purpose of calling it one-to-one and referring to one-to-one is that if it's one-to-one, then its inverse is a function. And we really want that to happen. If the inverse is not a function, then we cannot work with it the way we want to work with it. Okay. So I think we're a little bit past where we got to last time. So here's what the sine graph looks like. You guys now understand that. Is sine a function? It passes the vertical line test, right? Any vertical line that I draw hits my graph at most once, right? Also, by saying f of x, we're saying it's a function there too. Is the sine graph, does it pass the horizontal line test? I can see at least one horizontal line that hits in more than one place. So what that means is, this is not one-to-one. Sine is not one-to-one, which means that inverse is not a function. And in mathematics, that's bad. We want it to be a function. So what we're going to do is, we're going to ignore part of the graph, and ignoring part of the graph is not a very mathematical term. The mathematical term would be to restrict the domain. What I'm going to do is, I'm going to say I'm going to ignore everything to the right of this and to the left of that. I'm just going to look at this section of the sine graph. Okay? So if I ignore part of the graph, mathematically I'm restricting the domain. If I'm only looking at this piece, is that piece one-to-one? So that's the piece that we choose to use for inverse sine, so that inverse sine is a function. So, notice, now when we switch input and output, we're switching the axis as well. If the y-axis went from -1 to 1 for the y-axis, and we switch input and output, -1 to 1 becomes our x values instead of our y values, right? And our x values were -pi/2 to +pi/2. So when we switch input and output, now -pi/2 to +pi/2 becomes our y values. Does that make sense? Yeah. So let's look at a couple points here too, so I think that will help you see. If a function has a point at 0, 0, like sine does, you should be able to switch x and y, switch the input and the output, and you should be able to get a point on the inverse. Well, 0, 0 is not very interesting. But what about this point? What is that point on sine? Okay. So if pi/2 1 exists on the function, then its inverse will have a point at 1. Ignore that part of the graph. Let's write something like 1 pi/2. You see how it still hits that point? You're switching x and y. You're swapping input with output. And you can do this with all kinds of things. If it hits -pi/2, -1 on the function, then it's going to hit -1, -pi/2 on the inverse. Alright, so because we can't use the entire sine graph, we have to restrict the domain, which therefore restricts the range of inverse sine. So the range of inverse sine is from -pi/2 to +pi/2. So you need to write this. The range is from -pi/2 to +pi/2. Okay, so all the way back up to question 3. I said there is infinitely many spots where sine is square root of 3/2. However, only one of those is in the right range. You can only get values of this between -pi/2 and +pi/2 for inverse sine. So which of these angles is between -pi/2 and +pi/2? So that is the only correct answer. And the only way I know that's the right answer is because I know the range of inverse sine. Now, to spare you going through all 6 trig functions the same way, although you need to understand that you could graph all 6 trig functions, you could restrict the domain of them, you could switch the domain and the range, the inverse functions, and there you have your domain and range of all your inverse functions. That is common. You can do that. That is a very great mathematical approach to it. But most of us don't want to do that. I wanted you to at least see where it comes from, so you're not just memorizing stuff to get the right answer. Not just something that somebody pulled out of the air and felt like it could be good questions to do. We just said the range of inverse sine is negative pi over 2 to positive pi over 2. Okay? Now, as an inequality, it would be like saying this. Range over y values. So y is greater than or equal to negative pi over 2 or less than or equal to positive pi over 2. And you can memorize them these ways if you want to. That's the next handout. I'm going to have to rewrite these again. I think we will ask you to write like this for us and like this. But visually, what works for most everybody is the unit circle description. That's kind of a visual that represents the same thing. You need answers between negative pi over 2 and positive pi. So I can show the cosine graph. I take you straight to the range of the cosine, or the domain of the cosine graph. You can then switch the x and y values of the points, and you could graph inverse cosine, and we'll do that next time. But for our purposes, we really just need to know that the range of inverse cosine looks like this. So y has to be greater than or equal to 0, but less than or equal to pi. Or as an interval, it looks like that. We need to know that inverse cosecant, again, we could go through all those hoops again, but at the end, inverse cosecant looks like this, except it's undefined at 0. So its inequality would be negative pi over 2 to 0, but don't include 0. And then 0 to positive pi over 2, again, don't include 0. 0 doesn't exist. Or in, oh, I'm sorry, that's interval notation. Inequality notation, you'd have to say like y is, I don't really like inequality notation, but y is greater than or equal to negative pi over 2, but less than 0. And also where y is greater than 0, but less than or equal to pi over 2. Inequality notation is kind of a thing. Now, there is quite a bit of pattern here, so I'm going to start to point it out to you. How does sine and cosecant, what's the relationship between those two? And the reciprocals, and they notice that the range of those two are almost the same, right? But this one doesn't exist in the middle, so we have to take out that value. Or isn't inverse, or isn't cosine and secant, aren't those reciprocal functions? So what would you guess its range looks like? The same except for what? That is undefined there in the middle. Okay, so our inequality could say y can be greater than 0 or equal to 0, if we can hit this point, but less than pi over 2, or it could be bigger than pi over 2 and less than or equal to pi. We have to split it into two sections there. The stuff before the undefined point and stuff after. Or in interval notation, you could say 0 to pi over 2, but don't include pi over 2, and then pi over 2 to pi, but again, don't include pi over 2. the range of the inverse tangent, without making you go through the whole graph, looks a lot like the range of inverse sine, except it does not exist at the endpoints. It's undefined at the ends. So our inequality could say y is greater than negative pi over 2, but less than positive pi over 2. How would I write that in interval notation? So compare these two. They look the same, right? So this one includes the endpoints, so brackets, this one doesn't include the endpoints, so can choose okay. And then inverse cotangent. The range of inverse cotangent looks like this. So you're welcome to take any approach that's going to work for you. But I can tell you from experience that what works for most people is these unit circle visualizations. So our inequality here, we could say y has to be greater than 0 but less than pi. Don't include the endpoints, or 0 to pi parentheses will include the endpoints. Okay, so let me give you an example or two, even though we're going to do some on the worksheet too. So I want you to see why it's important for you to memorize this. Actually, before I do that, so there's a ton of connection here. These two are reciprocals. Notice they look the same, except this one has a hole in the middle. These two are reciprocals, so their ranges look the same, except this one has a hole in the middle. What about sine and cosine? What's the name of that identity that relates sine and cosine? Cofunctions? Remember cofunctions? Sine and cosine are cofunctions. How would you describe this graph to this graph? It's like a rotation. Do you see that? Well, these two are cofunctions also. Do you see how if you turn this one, you get this one? And tangent and cotangent are cofunctions. So if you were to rotate this one, you could get that one. So if you know which ones are cofunctions, 3 of them are just terms of the other 2. So it makes it a little bit less to memorize. But how this is going to get used is where you need to know, like, what is the about the inverse sine of negative 1/2. Questions like this is exactly what you will see in the quiz, or one question. So you're going to have to say, well, I know on the unit circle where sine is negative 1/2, it is right here and right here. You don't want to have to think about that for a minute. Step 2, you're going to have to say, I know the range of inverse sine is negative pi over 2 to positive pi over 2. So that's how I know this location is going to be my answer. That location is not, because we can only have one answer. Functions only have one output. Then we have to make sure that we actually give an answer between negative pi over 2 and positive pi over 2, because that's the range. So what do we normally call this location? 11 pi over 6. Okay. Do you see that 11 pi over 6 is not an acceptable answer? Why? It's not between these two values, right? Just because it's a location, inverse sine only exists between these two. So instead of calling it 11 pi over 6, you would want to call it negative pi over 6. That's the one and only acceptable answer. So you need to appreciate 1, that you're going to need to know the unit circle. And 2, is you're going to have to memorize these ranges so that you know which one to pick from. And 3, you got to be very careful that your answer is actually between those values and not just at the right spot. Okay. So to finish off the notes, about half of the questions roughly are referring to the unit circle. About half the questions ask you to sketch a triangle. So we'll have some that we look at today that look like this. and then wants to know what is the cosine of arcsine of slash 2x. And since this is not referring to the unit circle, nowhere on the unit circle do I have sine ratios of 2x. That is my big hint. Sketch a triangle. If it is not referring to the unit circle, it is wanting you to make a triangle. Alright, well, sometimes it matters which quadrant we put it in. A lot of times we get it right just out of coincidence. Is this 2x, is this positive or negative? Okay, it's a positive 2x, it's implied. And what quadrants does inverse sine work within? 1 and 4, because the range of inverse sine is this. So between 1 and 4, which one of those quadrants would have a positive sign? So between those two things, I know that I can sketch a triangle in quadrant 1. Its sine is 2x, so it's opposite to its hypotenuse. It'd be 2x to 1. How do we normally find the third side of the triangle? Pythagorean theorem. So just because they're not numbers doesn't mean that Pythagorean theorem doesn't still work here. Okay, so one leg is 2x. So 2x times 2x would be 4x squared. I don't know this leg. And then 1 times 1 is 1. So b squared is 1 minus 4x squared. And therefore b is the square root of 1 minus 4x squared. So if that side length was in terms of x, this side length is going to be in terms of x too. I don't have a numerical value, but so what? So this, because I couldn't tell you where that angle occurs, because I'm referring to the unit circle, the next best thing I could do is draw it for you. This is the angle that has a sine of 2x. Its opposite to its hypotenuse is 2x. Okay, well now it just wants to know what's the cosine of that angle. So do I have enough information now? Just pair up adjacent over hypotenuse. That would be the answer to the question. Okay, so we're going to practice this stuff with our sheet 1. But you needed to see that if it's not about the unit circle, then it's going to be about sketching a triangle like this. Just try to